Good morning, students. This is Dr. Eustace Russell, working as assistant professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are discussing the subject called kinematics and dynamics of machinery, subject code of MR3451 under the regulation of 2021 for the semester, fourth semester for second year students. So for the previous three videos, you have seen the subject topic called force analysis, and we have seen the constant forces, applied forces, static equilibrium conditions, and the various force members, 2 and 3 force members we have seen so far. And especially in the previous video, we have solved two basic problems of various 4-bar chain mechanism, as a single slider mechanism also we have seen. And we have discussed how to draw the free body diagram and the polygon based on the free body diagram, how to get a closing polygon, and based on that how to measure the dimension, and finally we calculated the static forces along the various force members. So today we are going to see the left out topics in the unit 4. We will see in the upcoming slides. So already we have seen some of the basic concept that is coming, and like static force analysis, various dynamic force analysis. Today mainly we are focusing on D elements principle, and based on that some basic topics also we will see in these upcoming slides. So what is the dynamic forces? Before going on to the D elements principle, we have to know that what is the major purpose of these dynamic forces. Dynamic forces are associated with accelerating masses. So dynamic means, as the name itself, we can clearly know that it having some motion, that is accelerating masses. Some car, some moving particle, or some object that is moving. Based on the masses, it will have some particular motion. As all machines have some accelerating parts, dynamic forces are always present when the machines operate. In situations where dynamic forces are dominant or comparable with magnitude of external forces and operating speeds are high, dynamic analysis has to be carried out. For example, in case of rotors, they rotate at a speed of more than 80,000 rpm. Even the slightest eccentricity of the center of mass in the axis of the rotation produces very high dynamic forces. This may lead to vibration, wear, noise, or even machine failure. This everybody understand that when it is not eccentric, it is not meeting at one particular point, it is diverted from the center point. Automatically some deviation will cause the most very high vibration because of the high dynamic forces will implement because of this eccentricity of the center of the mass. So this leads to the vibration, wear, and the noise, or even it will cause to the failure to the machine. So let us see in this slide the important topic called D elements principle. D elements principle states that inertia forces and coupled and external forces and torque on a body together give statical equilibrium. Inertia is a property of matter by virtue of which a body resists any change in velocity. Therefore, inertia force Fi equal to minus m Fg. M equal to mass of the body. Fg equal to acceleration of center of mass of the body. Negative sign indicates that the force acts in an opposite direction to the that of the acceleration. The force acts through the center of mass of the body. Similarly, all inertia coupled resist any change in the angular velocity. Therefore, inertia coupled Ca equal to minus Ig alpha. Alpha is nothing but angular acceleration of the body. Ig equal to moment of inertia about an axis passing through the center of mass G and perpendicular to the plane of rotation of the body. So D elements principle states that inertia force Fi equal to minus m Fg. So this center of gravity, everything we have seen in the engineering mechanics subject also. We have studied that what is the moment of inertia, everything we have studied the basic concepts. Based on that, again we are following the same topics. So sigma F equal to F1, comma F2, comma F3, etc. equal to external forces on a body. Then torque T1, T2, T3, that is the external torque on a body about the center of mass G. Now, dynamic analysis of four link mechanisms. For dynamic analysis of four link mechanisms, the following procedure. So, every problem having some steps we have followed in the previous topics also. Here also having some steps is there. First, we have to draw the velocity and acceleration diagram of the mechanism from the configuration diagram. What is a configuration diagram? It's nothing but a space diagram. What is given in the question? That is nothing but a configuration diagram. First, based on the dimension, what you are drawing, that is a space diagram. It is not a free body diagram. Determine the linear acceleration of the centers of masses of various links and also the angular acceleration of the links. Calculate the inertia forces and inertia couples from the relationships Fi equal to minus m Fg and Ca equal to minus Ig alpha. Replace Fi with equivalent offset inertia force to take into account Fi as well as Ci. Assume equivalent offset inertia forces on the links as static forces and analyze the mechanism by any of the methods. Here we can see the velocity and acceleration of the piston. That is a dynamic analysis of slider crank mechanism. Here we can see that one crank is there. There is the inner dead center and the outer dead center is given. Whenever the crank is moving from the inner dead center to the outer dead center, what will happen? There will be some displacement that it will be given as x point. That is clearly we can see that B1 B equal to nothing but what? BO minus B1O. That is the difference of this distance. O is the fixed point of the crank. Crank, what is that is fixed to the point O. Based on the substitution of the dimensions, we can write B1 A1 plus A1 O. Then BO is nothing but the length of the connecting rod. We can clearly write that. Now, plus R is nothing but the radius of the crank. Now, based on that cos beta and cos theta, based on the trigonometry, we can write like that. And the substitution followed by the substitution, we will getting that cos beta equal to 1 by n root of n square minus sine square theta. The connecting rod is very large as compared to the crank. N square will be large, and the maximum value of sine square theta can be unity. Therefore, we can take as root of n square. We can cancel out that sine square theta. We can take simply square root of n square. Will get cancelled to get n. Then you will get the final answer x is equal to r into 1 minus cos theta. This expression is for mainly simple harmonic motion. The point that is piston executes a simple harmonic motion when the connecting rod is large. Then it is followed by again velocity and acceleration of the piston. What is the velocity? How it will be whenever that is moving already automatically there will be some velocity and acceleration to the particular piston. So V equal to dx by dt. We can write for our simplicity dividing and multiplying by d theta. Then based on the substitution, we can write like this. So r into 1 minus cos theta plus n minus n square minus sine square theta. That is coming as a square root. That is half. This is a substitution of x, and outside you will get d theta by dt. Then we are going to substitute. Sorry, we are going to differentiate. Okay, with respect to d theta. Then cos theta will become sin theta. Then again, we are going to substitute to get these values. So sin square theta will become 2 sin theta. The differentiation of sin theta will become as cos theta. Why this omega is coming means because d theta by dt is nothing but omega. That is angular velocity. The final substitution will get like this: r omega sin theta plus sin 2 theta by 2 of square root n square minus sin square theta. If n square is large compared to sin square theta, then you will get Actually, in the previous slide also we have seen the same thing. Sine square theta will get cancelled, and the root of n square will become n. Then we can write V equal to R omega sine theta. Then acceleration of the piston also we can write like this. The same thing, F equal to dV by theta. The previous thing we wrote like that now, d theta by dt. Just like that here. Uh, in the previous we wrote like dx by dt. Here it is dV by dt. Change in velocity with respect to time. The same substitution again we are doing. Based on the substitution, you will get r omega square cos theta plus cos 2 theta by n. So if it is very large means what you can write, that portion will get cancelled. Then f equal to r omega square cos theta in case of SHM, that is simple harmonic motion. So when we are applying some condition of theta equal to 0 and theta equal to 180, based on that we will get the expression like this: r omega square 1 plus 1 by n, r omega square inside the bracket minus 1 plus 1 by n. So the expression of acceleration has been obtained by differentiating the approximate expression for the velocity. So these are the various expressions we have seen here. So this is the reference which I used for preparing the content used in this slide. Kindly go through it. So kindly thank you students for your kind attention. Kindly subscribe the channel, share this video to your friends. So successfully we have completed the force analysis topic. So in upcoming classes we will see the unit 5, that is balancing and vibration. That is important as well as interesting subject to you. So we will meet in the upcoming classes. Thank you.